9394 quiz review. Here we go. Number 1. So for 1 and 2, it looks like we have a shape to the right, which is a rhombus. So knowing that you're a rhombus comes with lots of properties. We have 4 equal sides, so that's probably going to be helpful. It looks like this problem's involving angles. So with the rhombus, some things you want to know is that the first one is the diagonals bisect the angles. All right, so they bisect the corners. And then also, another feature is that the diagonals are perpendicular or 90 degrees to each other. That really helps. So these 4 are all 90s. Basically, we end up with 4 congruent triangles inside there. So we know the answer to R. R is 90 degrees. And we can find the value of S. So because of the fact that the diagonals bisect the angles, I know that this 48 is bisected, and we have another 48. And opposite angles are congruent because it is a special parallelogram. So these are both 48. And then because we know the 90, S just fulfills the triangle sum. So S is going to be 42, 42, 42, 42. So we got everybody on lockdown. Angle S is 42 degrees. All right, moving right along. We have a rectangle. All right, so we need to know a couple key features about a rectangle. We know that rectangles have 4 90-degree angles. That's going to be useful, right there and all the way around. I think I'm going to make that a little bit lighter so it's not quite so, it's not yelling at me so much. And then we also know some things about the diagonals, that the diags, not the digs, the diags are congruent to each other. So they're the same length. So find the value of y. That's the first thing. Well, let's start working on these angles. So if it has up to 90, 90 minus 61 is 29 degrees. So I got this corner locked down. Now, because the diagonals are congruent, and because of parallelograms, diagonals bisect each other, this piece equals this piece, which equals this piece, which equals this piece. So I have an isosceles triangle. So down here on the bottom, that means this other base angle is going to be 29, which should allow me to find y, because 29 and 29 are 58. And when I subtract from 180, that gives me 122. So y is 122 degrees, vertical angles. Now I can play linear pair and subtract from 180 and get 58 and get 58. Because we have isosceles triangles on the sides, this is a 61, which means these guys are 61s. And then the 29s, kind of symmetry, they flop up here to the top to fulfill the 90s. We basically got everybody on lockdown. So find the value of y. That was 122 degrees. Find the value of x. Well, x comes from hj is this diagonal, and ik is this diagonal. And they have to be equal to each other. So I know that hj has to equal ik, which should allow me to solve for x. Minus 3x from both sides. Add the 11 to both sides. And we find out that x equals 10. So there's your correct answer for number 4. Now, be ready to, so if x equals 10, and let me kind of just redraw, let me get rid of some of this stuff over here, some of this clutter. Be ready for on the quiz that if x equals 10, that can give us the length of this. If I plug 10 in here, 5 times 10 is 50 minus 11, that's 39. So I know that this piece is 39. Well, let's say that I wanted you to find ij. Let's say that I was like, hey, how long is ij? You should have enough information based on that, because We knew that this was 29 degrees. So ultimately, we could use trigonometry. You know, we have 29 degrees, and we have a hypotenuse of 39. If we need to figure out what this piece is, all right, if we wanted to figure out that, let's give it a letter. Let's call it A. I could just use trig. You know, I could put my guy over here, and that's opposite and hypotenuse. So I could use sine. I could say, hey, man, the sine of 29 degrees is A over 39. And then we could multiply those out, and we could figure out. I just wanted to show you that you can use trig to find some missing pieces if needed. We got a trapezoid on our hands. So what do we know about a trapezoid? Not much. A couple key facts of a trapezoid are we have one set of parallel sides. On this problem, it appears that it's ML and IK, milk. But then we also do know that this mid-segment here, this is referred to as the mid-segment, which I don't think I told you in the instructions, but hopefully you assume that. I think I told you in class when we went over this, that a mid-segment, it chops them both in half, and the mid-segment is parallel, and it's the average of the bases. So we have a top base, we have a bottom base. If we average those two together, so if we add them up, divide that by 2, so that's 42 divided by 2, we get an answer of 21. So that's number 5. Find the measure of angle K. Well, because these are all parallel lines, you know, this line is parallel, this line is parallel, this line was parallel. This line over here acts as a transversal, and it creates our parallel line properties, so that like these two right here are consecutive interior, so they have to add up to 180. But then you have this this copy going on down here. So K is actually 107 degrees. All right, moving right along. Find the area of a trapezoid. Well, the area of a trapezoid, some things that how I remember this is, I know that the area of a rectangle is base times height. I know that the area of a triangle is 1/2 base times height. Well, I know that the area of a trapezoid is the average of the bases times the height. So one base is too small, one base is too big. We got to figure out what's just right. Well, we have our two bases, 10 and 13. So we need to average those. Basically, what we're finding is we're finding this mid-segment. Now, you could add them up and do 23 divided by 2. That's fine. That's how you can get the average base. Or you can just look at 10 and 13 and realize that 11.5 is the number right in the middle. So average base times height, which is 4, should give me an answer of, what's that, 46. So the correct answer for the area for this trapezoid is 46. Area of a parallelogram, which is effectively the same as a rectangle, because we could chop off that piece that I have perforated there and slide it over, translate it over, and it would be a rectangle. But we need to find the area. So area of a parallelogram is pretty easy. It's just base times height, because we do know the opposite sides are the same. So both of these sides, since it's a parallelogram, have to be 18. So there's no need to average them. The base is 18. The height is 9. This one's just plug and chug. That's 90 and 72 is 162. Next one, area of a kite. Well, if you didn't know the area of a kite, you could find the 4 triangles separately. That's one way to do it. But there is a nice formula. The area of a kite is just 1/2 diagonal times diagonal. It's kind of a shortened version if you find all the triangles and then put it together. So we have two diagonals. I'll call D1 the blue one, and I'll call D2 the red one. And let's crank this out. So we have 1/2, and the blue diagonal is 1, 2, 3, 4, 5, 6, 7, 8, 9. And the red diagonal is 1, 2, 3, 4, 5, 6. So that's half of 54, which should come out to be 27. Got it. Number 10. I think this one's a little more involved. Find the area. You're going to have to use trig or a special right triangle to find the missing dimensions. So when I think about my formula, so my formula for a trapezoid, and I probably should have told you this is a trapezoid. Again, on the quiz I'll be very clear, but those are parallel, so this is a trapezoid. And the area for any trapezoid is the average of the bases. So you add the bases up, you divide it by 2, and then you times it by the height. Well, we're missing some things. We do have both bases. So we have the 12 and we have the 20, and we can chop that in half. We're missing the height though. Well, let's calculate this. That's 32 divided by 2, that's 16. So now we just got to figure out what h is. So that's where I'm going to use these other numbers here. And if I come over, I'm like, okay, you're h. So let's focus our attention on this 30, 60, 90 triangle, which, if you remember, you could use special right triangle properties. Now, this is shorter because if the hypotenuse is 10, the small side is half of 10, which is 5. And then the middle leg, the 60-degree side, is just 5 radical 3, which comes out to be, let's see, 5 times radical 3 is about 8.66, 8.7. So regardless if you use one of those two numbers, if we use an intermediate value and we round it, I could do that if I wanted. I'm going to put 6 in there. So that could give me the answer. If you forget your special right triangle properties, you could have just used good old SOHCAHTOA, and you could have put your guy here, and you could have said, well, this is opposite. This is, well, we didn't know the 5 if you didn't know your special right triangles. And this would be hypotenuse. And you could use sine. You could say, hey, the sine of 60 degrees is opposite over hypotenuse. And you get h equals 10 times the sine of 60. And that will also give you 8.66. And then I know some of you guys love the law of sines. So you law of sines lovers, you could use that setup. And you could say, hey, the sine of 90 over the side across from him equals the sine of 60 and the side across from him. And you could shake and bake and do some multiplying. And you would also, times those two together, divide by this, you would also get 8.66. So what is the final answer? 16 times 8.66. 138.6 is the area that we're looking for. All right. Well, hopefully that helped you out with some parallelogram properties, some area formulas, and all that type of good stuff. See you.